Okay, we're going to talk today. We've talked a lot about simplifying rational expressions, solving rational equations. Now we're going to move into rational functions. So really looking at those on the graph, and I know we've talked a lot about asymptotes and what those look like. Today we're going to talk about finding asymptotes algebraically. So we won't be using graphs very much except to check our work. So let's look at our key terms. Our first term is asymptote, and I know that you guys already know this, but we're going to go ahead and put it down on paper so you can have it. An asymptote is basically a boundary line. So as far as a boundary line goes, it can be horizontal. It can also be vertical. And something that we won't look at until later, it can also be a diagonal line. I'm just going to write diagonal for these purposes, but we'll really learn more about what those are later. So let's talk about a horizontal asymptote. A horizontal asymptote is always written in the form of a y equals line. So it's horizontal, it's going left to right. A vertical, we've really talked about vertical more than anything, is going to be an x equals line, and it's that up and down, going negative to positive, up and down. So key strategies here, go ahead and look out for these. We only have 3 examples for our notes, but look out for these as we talk about them. A couple of different terms that I want to talk about are the vertical asymptotes and the horizontal asymptotes. When you're looking for horizontal and vertical asymptotes algebraically, we're going to be looking at the leading coefficients and the powers. So first, in our examples, we're going to be finding domain, the asymptotes, and any points of discontinuity. So remember, those points of discontinuity are found when we're simplifying the rational expression, and then they can cancel. So that becomes a point of discontinuity, or what we talked about as a whole. So today we're going to be more talking about these asymptotes. So a vertical asymptote can be found. A vertical asymptote can be found by setting the denominator of the function equal to 0, right? So that's also the way to find the domain, is to find out what x values can be or a part of the graph or not part of the graph. But in this case, we're actually finding that x equals line, right? So if I have a function f of x equals, let's say it's 2 divided by x minus 1, I'm going to find the vertical asymptote by setting x minus 1 equal to 0. So it would look like this, x minus 1 equals 0. So my x equals 1, that would be my vertical asymptote, right? So for the case of simplicity here, we're just going to be labeling it like this, VA for vertical asymptote. In the case of horizontal, it's a little bit trickier because we have to look specifically at the powers, the degrees, and the degrees of the function, and then we're going to have to be doing a little bit of math. So there's a note here in your notes about horizontal asymptotes. So thinking about this, if f of x is n of x divided by d of x, at y equals 0, if the degree of the leading variable of d of x is greater. So let's talk about what this means. I'm going to move this over so we can see them both at the same time. Maybe I can manage it. All right, so that was vertical. Now let's move on to horizontal. Remember, it's going to be written as a y equals, and it's going left to right, okay? So these specific rational functions are actually called hyperbolas, which we'll learn about a little bit more later. But it says if d of x is greater. So what does that mean? Well, let's look back here. The degree of my numerator here is 0, right? Because it's x equals 0, that's 1. The degree of the denominator is 1. In this case, the degree of the denominator is greater. Therefore, in this function, in this example, f of x equals 2 divided by x minus 1, the horizontal asymptote is y equals 0, so it's through the origin, okay? So let's look at my next note. It says at y equals the ratio of the leading coefficients if the leading variable degrees are equal. So let's see what that would look like. If my variables are equal, that would look like this. If this was 2x and the denominator is x minus 1, see how my degree of my numerator is 1 and the degree of the denominator is also 1. So that means my leading coefficients, whereas this is 2 and this is 1, my horizontal asymptote is y equals that ratio of 2 divided by 1. In this case, it would just be 2, right? All right, so let's look at our third note. So we've looked at when my degree is larger in the denominator, when my degrees are the same, and now when my degree is larger in the numerator, let's see what that looks like. So I'm just going to take the example that we've been using. Let's just flip them like this, x minus 1 over 2. And notice that the degree in the numerator is 1, the degree in the denominator is 0. There is no horizontal asymptote in this case. So we're going to say horizontal asymptote, none, right? That's my answer. All right. So because we know we've talked about how to find vertical, right? Setting the denominator equal to 0, and that becomes your vertical asymptote. And then we've also talked about how to find your horizontal. Keep in mind there are 3 different things that you need to be looking for, right? In that horizontal asymptote, and really you're going to be looking for the degree. So look for the degree of the numerator and denominator, okay? That could be a key strategy. All right, so let's look at our examples. We have example number 1. I want to know, first of all, what's my domain? And then, what are my asymptotes and if there are any points of discontinuity. So here we go. Example 1 says f of x equals 2 divided by x minus 3. So when I'm finding my domain, my horizontal asymptote and my vertical asymptote, we'll just make our 3 columns here. So my domain is setting my denominator equal to 0, right, to see what x cannot equal. So x minus 3 equals 0, x equals 3. So x cannot equal 3, right? So my domain is going to be that negative infinity to 3, right? Cannot equal 3. And then 3 to positive infinity. So that's my domain. Domain is right there. My horizontal asymptote in this case is the same thing. We set it equal to 0, except this tells us if it's an asymptote. So x equals 3 here. So this line is actually my asymptote. Notice they're the same numbers, but we're actually telling 2 different things from these numbers. Then my vertical asymptote, I have to go back to my notes and look at my leading degree. If my leading degree is greater on the bottom, what does it tell us? I'm going to go back to my notes and see what it tells us. It's okay to go back. Okay, if my degree is greater in the denominator, then my horizontal oh, I have those switched in my vertical asymptote. Horizontal asymptote. Then my horizontal asymptote is y equals 0, right? Okay, so let's check our work and see if we're actually correct. So I'm going to pull up my Desmos. I already have my graphs pulled in. I'm getting better about planning, aren't I? And I want to know, am I correct? Is my vertical asymptote at 3? It is. It's right here. And then is my horizontal asymptote through the origin y equals 0? It is. Okay, so we're checked out there. That's good. Let's look at example number 2. Example number 2 says, f of x equals 2x minus 1 divided by x. All right, so we want to find domain, and we want to find our vertical asymptote and our horizontal asymptote. So domain, I'm going to set my denominator equal to 0. So in this case, x cannot be 0, right? That cannot be 0. So my domain is going to be written like this: cannot include 0. So negative infinity to 0. I'm terrible at writing infinities. I don't know who writes infinities very well, but maybe loopy like that. Okay. Then my vertical asymptote is the same thing, setting my denominator equal to 0, and that is actually the vertical asymptote. It's that line through the origin, x equals 0. Then my horizontal asymptote, let's look back at our notes. I'm going to follow my degrees. Well, in this case, the degree in the numerator is 1. The degree in the denominator is also 1, so they match, meaning that my horizontal asymptote is the ratio of my leading coefficients. So my leading coefficient here is 2, and my leading coefficient here is 1. So y equals 2 divided by 1. In this case, y equals 2. So let's check and see if we're correct in finding our asymptotes in domain. All right, so it was the second one here. Let's get rid of that one. Okay, so x equals 0. That is correct. X equals 0 goes through the origin there. And then y equals 2, this horizontal line here. And that's correct as well. So that's great. Got that right. So in this case, we're just checking with Desmos. Let's look at our example number 3 and see if we come to something different. So example 3 says f of x equals 2 divided by x squared plus 1. Notice we didn't have any factoring going on here. That would be a key there. If we have examples with factoring, then we'll see if there are any points of discontinuity, but we don't have any here just because we're trying to do our math. So our domain, our vertical asymptote, and our horizontal asymptote, a little bit more math here going on. Okay, so I have, my domain is x squared plus 1. I'm setting it equal to 0. So x squared equals negative 1. No real solution, right? So if I have a no real solution, right, that's no real solution, that means that it's all real numbers there for domain. So you can write it like this. That's our domain. Oops, should probably square it. Right, vertical asymptote is the same. If you have a no real solution, then there are no vertical asymptotes there. A little bit different than what we've seen before. Then our horizontal asymptote, we're going to be looking back at our notes here. If my degree in the denominator is larger, degree in the numerator is 0, degree in denominator is 2, is larger, then my horizontal asymptote is at y equals 0. Not a whole lot of math there. So let's look at our Desmos graph and see if we're correct. Okay, so we said that it's all real numbers, which in this case, that's true. It is all real numbers. And then my horizontal asymptote is at y equals 0. So you can see the boundary line here is through the origin. Very cool. Very cool. Interesting. Little curve there. Okay, so that concludes our 7.6 rational functions notes.